Okay, so in the last example that we ended with, what did you start with? Besides the inequality that you were asked to solve, what did you start with? You started with a hint, right? And we did the synthetic division, and then we factored it, and then we made our sign chart based on the zeros. Okay, then we actually solved the question because they asked me when it was going to be greater than 0. That's only the positive interval, and so we told them when it was positive, between negative 2.5 and 1.5, and also between 4 and infinity.
I have a question.
Yes.
Why is it a parentheses suggested directly to the left of negative 2? Why is it parentheses?
Okay, great question. So, what would change this parenthesis right here from to a bracket? What would change that to a bracket? Go back to the original, which I don't have up here. It should be in your notes somewhere. What happens at negative 2 in our picture? What is the y value right there? It is actually 0. It's negative 2. All right, sorry, at negative 2. It is 0. Well, the inequality said greater than 0. It didn't say greater than or equal to. If it said greater than or equal to, would this parenthesis change to a bracket? Yes. What about this one over here? Would that change to a bracket? What's happening at 1.5? If it said greater than or equal to. Greater than or equal to, would you have put a bracket right there? Greater than or equal to. Wait a second. What is this y value right here at 1.5? 0. Does that fit in the category greater than or equal to? Yeah, it does now. Because you put the equal to on. You take the equal to off, now it's parenthesis, right? Bracket. Parenthesis. Bracket. Is this making sense? It's greater than, they can't include that spot. When you put the equal to on, suddenly it has to include that bracket, right? So you got the bracket. What about this one over here? Would that change to a bracket over here at 4? Yes. Yes. What about this one? Does it change to a bracket? No. No, thank you very much. Don't ever do that, otherwise the red pen of death is coming after you. You can't grab infinity. You will get thrown out of every single party there is out there if you try to put a bracket on infinity. Pretty sure there's laws against that. We go across every country of the world. Okay, I don't think some places you can lose hands for that. Okay, now, example 3. I've been given this inequality. What do you think I'm suggesting? With blue arrows on top of a blue net. That was horrible choice color. Oh my goodness, that was horrible. Should have done something better than that, you know? Like red or something. What am I suggesting? What? Yeah, push everything over to one side. Okay, so we got x cubed minus 6x squared. Then what? Plus 8x minus 2 is less than or equal to 0. Wait a sec, they didn't give me a hint. If you are not given any zeros, then you will be forced to pull out your graphing calculator and graph that thing. Now, I am pretty confident you can graph it, so I'm not going to probably continue this example. But yes, you would come here. Yes, you would put this in y1. You would find out the decimal versions where it crosses. I mean, I can look this up in the book and kind of give you the idea, but it's not it's not worth our time really to be typing on the calculator since we already know how to graph. Looks like it's at 0.32, 1.46, and 4.21. So 0.32. Okay, we need to go to 5. So 1, 2, 3, 4, 5. We had a 0.32. And then we had a 1.46. Somewhere in here. Nope, what? And a 4.21-ish. Just make sure you typed it in correctly, because if you miss a minus sign or a variable or a square or something like that, it will change things dramatically. So you graph the doggone thing, you know, see that it's doing, you know, something like this, and right? So answer their question. Answer their question. You got the picture. You found the zeros. I'm guessing we're going to have to alter our window to get something that's nice, that might show me a little bit better.
Oh yeah, that happens.
So just altering the window gave you a better looking shape. So we graphed it. We did our little calc 0 right that's above the trace button. And so let's answer the question. When is that polynomial function less than or equal to 0? You write down. There'll be two intervals that you should be writing down. Write them in your notes somewhere. Show me what you think based on the picture. What are you writing down? Just so you know, that would be fun. Right? The decimals, I'm not that concerned about. I'm more concerned about you found your close and then you're giving me the right intervals. Yeah. I'm thinking here. Oh, I know. So there's the picture, right? So with the picture and the zeros, you would be able to do that on the calculator. Answer that question. When is that thing less than or equal to 0? There should be two intervals that you have in your answer. Okay, now that says greater than or equal to 0.
That's that 0.32
Less than. So we're on the same page. It should be less than or equal to 0.
Yes. No, you got it right. You got the brackets right. Let's say that.
Okay, give me one of them. Yes, sir.
Negative infinity into 0.32 and 0.32 has a bracket.
Okay, he just told me that was one of the answers. One of the two answers. Do you agree or disagree? From negative infinity
Wait, no.
all the way over here to 0.32, including 0.32. Does that fit in the category? It does. Every single y value in that group is less than or equal to 0. Do like the bracket. That's nice. Union what?
1.46 to 4.21. Brackets or parentheses? Brackets. Thank you very much. Sorry. I had to mute it. Not that I need to be listening to Dog of Wisdom during this. Example 4, solve a polynomial inequality with unusual answers. Okay, so here we got this polynomial x squared. Woo. Lock. X squared plus 7 plus 2x squared plus 1. I want to know when that is greater than 0.
Don't use your calculator yet. Do not use your calculator or Desmos yet. I want you to tell me if you know any of the zeros. Tell me if you know any zeros.
Take a few seconds, talk to your neighbors, and see if they can come up with any zeros. I'll wait to see your response. Come up with any zeros to that polynomial that you can.
Okay, now that you've stared at it long enough, graph it on the calculator. Just exactly the way you see it right there, parentheses and all. Go to Y1, graph that thing. I think you'll find something interesting, Mr. Jim. And what did you find when you graphed it? Did you find something, for those of you who, the leading term of this, by the way, the leading term is 2x to the 4th. I'm going to guess that you got something, it opens up on both ends and maybe did something like this. Maybe not quite exactly like that, but it's pretty doggone close. And what's the most important thing about the picture you found? It never touched the x-axis, which is exactly what you were saying. Because both of those factors, what kind of quadratic factors are those? We used a word for that. Well, they produce, if you do allow me to go to imaginary numbers, I could factor these and get to complex factors, but we said we weren't going to do that. We were going to stop with the reals. But what word did I put in front of the quadratics that did not factor further? Started with an I. Irreducible. As long as you stick with real numbers only, these are irreducibles. But if you graph it, that should confirm, oh, hey, it never touched the x-axis. Okay, so let's see if you can answer my question. When is this polynomial greater than 0? Don't you want to say something? There's a word you want to use. A lot of you are going to say something like always, right? And so that, what does that mean? You guys have said it. Several of you have said it. Negative infinity to infinity. Now your question. Okay, so if I do zoom 6, let's see if we can get a basic picture of that. We might have to enlarge it. And sometimes they have that little hill in the middle. Sometimes they don't. Sometimes these fourths kind of look a little bit more like parabola type things than that. And sometimes they have that little shape to the middle. But the interesting thing is, notice that it never crossed the x-axis. That's the important part. And because you know that the end behavior should be up on both ends, it's never going to cross the x-axis. Okay, how about if I change it to greater than or equal to? A same exact answer, isn't it?
You're just asking me for more, and it fits everything in the first one. Why wouldn't it fit everything in the second one when you opened it up to a larger group? Okay, so what happens if I flip that around and I say less than 0? Never, right? You're going to use a word like never, or no solution, or some of your favorites like DNA. Right? Denny. Not D-E-N-N-Y. That's something different. Okay, unless you're hungry. What about less than or equal to 0? Same exact result, right? It's never in the negatives, so how in the world could it have a value there either that would work? Okay, so you do get some situations which are all or nothing. Okay, now we need to switch gears to the rationals. So, what was an important factor of the polynomials? Polynomials cross the x-axis, but polynomials never had what? Rational functions do have them, but polynomials never did. I'll give you a hint. They never had a vertical asymptote. So rational functions can cross the x-axis and have vertical asymptotes. So you got to look for both of those things. And horizontal asymptotes too. Okay, but we know that. So let's take a look at what we have here. We got y equals 2x plus 1 over x plus 3 times x plus 1. Hey, just for fun, I'm going to FOIL that bottom. What do we got there? X squared, 4x, and a plus 3. Okay, I might need that in a second. All right, how about zeros? Any zeros out there? Oh, I think you're thinking about vertical asymptotes, right? X equals -3 and x equals... Oh, I missed that. That's a minus, isn't it? Thank you for not correcting me. Gee whiz. Help me out here, folks. Okay, so that's a minus, so that's going to be x squared, 2x, and a minus 3. Okay. Life is back to normal. So I think you were thinking of the vertical asymptotes, but yeah, we need those. How about zeros? Where do we find zeros in this mess? Numerator. Set that numerator equal to 0 and tell me what you get. What do we get? -1/2. Right? Factors in the numerator create the zeros. Okay, now how do I find the horizontal asymptote? Take the what? Okay. I had 3 words that I love to say every time we do horizontal asymptote. Take the... Ooh. Starts with an L. Limit. As x approaches what? Okay, folks. Horizontal asymptotes. Where are we finding those on the graph? Infinity, right? Or negative infinity. Not at 0. Go to infinity. Okay. Man, you would have thought you have seen this enough that you would have repeated it verbatim. Take the limit as x approaches infinity of... now, I knew what you were getting at when you were saying something about this. Largest power of x in the top, largest power of x in the bottom. What is that reduced to? 2 over x. Okay, because one of the x's cancels out. So as x gets bigger and bigger and bigger and bigger and bigger, what happens to that fraction? It becomes 0. Gets closer and closer, as you said, to 0. So guess what? We got our horizontal asymptote y equals 0. Yes.
Why is horizontal asymptote
The vertical asymptote is found quicker because you can take the factors in the denominator, set them equal to 0. That's where you would be getting that infinite discontinuity situation going on. Whereas horizontal asymptotes, you really need to look way far left and right on the graph to find out what's going on the graph. And so, we could write out vertical asymptotes as limits, left, from the right, overall, that kind of thing. But we can quickly identify them by looking at factors in our denominator. Can't quite do that with the horizontal asymptotes. Okay, so we got that information. It's time to graph. So I got my vertical asymptote here, and I got another vertical asymptote here. And then I got a 0 at -1/2. I need to pick an x value to plug in this section over here. -4, okay, that's a good one. I need to pick an x value in this section right here. Now notice in this section that I've chosen, there's a vertical asymptote on the left, but a 0 on the right. What are you going to pick in there? -2, okay. I need a value in this section right here from -1/2 to the vertical asymptote. 0 would work. I love 0. It makes so many things disappear. But no. Okay, I can't record this joke.
What's the little dot that's like right beside the center?
You mean right here? That's my 0 at -1/2. I had an x-intercept right there. And then over here, I need something over here in this section. What would you like to pick? 2? Okay. Now I'm going to start this with you, just like we did with the polynomials. And we are dealing with this 2x plus 1. Remember, I don't care what the number is. I just want to know whether it's positive or negative. So you told me to plug in -4, so I'm coming up here to the top. 2 times -4 plus 1. Is that positive or negative? That is negative. Over, what is -4 plus 3? Positive or negative? Negative. And how about -4 minus 1? So if I have a negative divided by the product of two negatives, what do I end up getting? So this section over here is negative. Okay, you go through the other 3 sections right now and figure out, use a little fraction, kind of like I did right here, and decide what those other 3 sections are going to be. Go. Pick one of the values that we have that we decided. We decided -2, 0, and +2 for the other 3 values. So which one would you like? Okay, so 2. If I come up here, 2 times 2 plus 1, is that positive or negative?
fraction up here. Okay, so you'd be over here and so you'd have a little plus and a fraction. And then you're going to do the same thing with the two factors on the bottom. You're going to plug in 2 and decide whether this one's positive or negative, or this one's positive. Then look at the overall thing and say, what would I get out of this? Would I get a positive number or a negative? Correct. You have to be able to cancel out the negatives. And if you can't, if there's one left over, then all of them are negative. So in here, now that's not x plus 1, that's x minus 1, I believe.
That because I made that mistake and then we had to change that at the beginning. So yeah, so make sure you get that corrected.
Yeah. Well, you get a 0 in the bottom, kill the whole denominator, and that's why we put those places in the graph first, so we would not choose. It wouldn't make any sense for me to pick negative. I get 0, it doesn't give any information. Right, but ideally, all I'm interested in is the pluses and the minuses, and yeah, you can. It's the same as that. I don't care about the number. I just care about whether it's positive or negative. Okay, just to get the basic idea. Anybody stuck over here on this side? Okay, now there's 3 sections. 1, 2, 3 there. And you're just telling me about 2 of them. So you found this one and this one. So what's inside here? We said we were going to plug in a -2. Negative there, positive there, and negative there. I think you did that.
This one's probably this one's
Oh, yes. Okay, what's your We're going to find out here, so I'm going to go through it with everybody.
So if I pick -2 and go back to my top here, -2 times 2 plus 1. Is that a positive or a negative number? -2 times 2 plus 1. That is a negative number. Over -2 plus 3. Definitely a positive number. -2 minus 1. Negative number. So when you take a negative over the product of a positive and a negative, what do you get? That has to be a positive number. Here, let's switch to a different color. So this section in here is positive. Okay, well, if you want me to write it out, 2 times -2 plus 1. Oops, don't need that. Okay, that right there is going to give me a negative value. On the bottom, if I plug in -2 plus 3, that's going to give me a positive amount. And then -2 minus 1 is going to give me a negative amount. Well, if you take these two are going to cancel each other out. So overall, the quotient is going to be a positive number. Does that kind of help? I don't really care what the number is. I care whether it's positive or negative. I'm just thinking through my, in my mind, whether that's going to be a positive number or a negative number. And if it makes more sense to you to actually find the number, okay, that's fine too. Yeah, you had 2 negatives, And those two negatives cancel each other out, which helps me understand why that section is positive. I need the space here, otherwise I wouldn't be erasing this. So next, you said let's plug in a 0. So 2 times 0 plus 1. Well, I wish I had this a little bit. 2x plus 1 over x. Is it x plus 3, x minus 1? So I can do this a little bit easier when it's blown up like this. So I'm plugging in a 0. 2 times 0 plus 1, that's a positive number. 0 plus 3, that's a positive number. 0 minus 1, that's a negative. So what do you think overall is going to happen when you divide that out? You're going to get a negative section. So right here is a negative section between the 0 and that asymptote. So what happens over with the 2? You know what? I'm going to get rid of this and this and this just to make it a little easier to read. And just come in here and make that look a little prettier. Okay, so when I plug in a 2, 2 times 2 plus 1, that's positive. 2 plus 3, also positive. 2 minus 1, also positive. So what's that section going to be? This whole section over here is positive. Now, you said a little while ago that we had a horizontal asymptote at y equals 0 running through this graph. We have seen these rational functions and what they look like. So if you're telling me on the right side of the graph we have to have a positive section and it can't touch the asymptotes, it's got to look something like this. Now, nobody says I have to draw the graph. I just am trying to do this to help us visualize what's going on. If it's negative in the section between the vertical asymptote and the 0, it's probably doing something like this. And if it's positive between the 0 and the vertical asymptote over here, it's going to be going like that. What do you think is going to happen on the left side of the vertical asymptote at x equals negative 3? It's going to be down here, because we said that all those y values had to be negative. I bet we can answer the question. The question was, when is it 0? Well, we kind of already answered that, right? We said negative 1/2. Part B, when is it undefined? We also said that, right? X equals negative 3, x equals 1. When is it positive? When is it positive? There's 2 intervals where it's positive. What are they? Negative 3 to what?
Negative 3 to negative 1/2.
Ah, negative 1/2. Oh, it goes from the vertical asymptote to the 0. That's where it's positive. Where else? 1 to infinity. Okay, we get to letter D where it's asking about negative. There should be 2 intervals for that too. Negative infinity to what? To negative 3. Union. Negative 1/2, I hear you. To 1. Okay, example 6 goes back to some of the things we did in Algebra 2 and also in section 2.7. And all we're doing the rest of this week is practicing because you have a test on Friday. So we'll just be reviewing and practicing and going over problems to make sure we're ready on Friday. So let's see if we can remember how to get common denominators. What is the first denominator missing that the second one has? It's missing an x minus 1. So to the top and bottom of that fraction, I multiply x minus 1. What is the next fraction? What's the next denominator missing that the first one has? X plus 3, right? Top and bottom. Okay, so the denominator has an x minus 1 and an x plus 3. What do you get on the top? That's my question for you. Figure out what you get on the top. Yes, you need to distribute. Yes, you need to add like terms. Go. Other side, pretty much because it isn't really gonna matter. I don't need to worry about getting a common. If it was something else, then yes, I would do exactly what you're doing. So here, which is very similar to what we're doing right now, we have a factor. Now some of these, like this, is going to end up being in factor form when we get to the next part. But we're going to ask, okay, anything that's got a problem in the denominator, you can set the factors equal to 0. Those create your vertical asymptotes. So that's what we end up splitting the graph with this discontinuous. Oh, this is so similar. One was graphing the basic function. Now we add the whole, when is it less than 0, greater than 0? So you're changing it from an equation to an inequality or a function. So very similar type thing going on from here to here. So they should have some decent connections.
Pardon the interruption, just a reminder, there is after.
Good.
Make sure you are on time. Work down there at 45, we have attention. Also, if you have community service, tonight reports will this month.
What are my zeros? Hopefully you got 8x plus 4 in the numerator. X equals negative 1/2, right? Because you set the factor equal to 0 and solve. What are my vertical asymptotes? Negative 3 and x equals 1. Is this almost the exact same question as the last one? X squared plus 2x minus 3. It's got the exact same denominator. What's the only thing different about the numerator? Do you see a GCF in there you could pull out? 4 times 2. Oh my goodness, this is the exact same question. But what I need you to understand or look at, you've got your horizontal asymptote right in here, right? What do you do with this? 8x over x squared. Take the limit as x goes to infinity, and we already decided in the last question that went to what? Hey, don't pack up. It hurts my feelings. Plus, I'm still working here. We found out that our horizontal asymptote was y equals 0. All of this is exactly the same, so I can literally take you back to the previous graph to answer this question. So, when is that thing less than 0? Is it the answer to my previous question? A, B, C, or D? Which one of those answers example 6? That is D, where it's negative. So, yeah, you had to do a little bit of 2-7, right? Get common denominators, and then you could find your vertical asymptotes. But it's exactly the same thing as the previous example. Had a little bit of extra work in it. Any questions for any of those of you who actually care? Any? No? Okay.